Hey everybody. What I wanted to do today was to show you a computerized model of the celestial sphere. And there's a worksheet that goes with this. It looks like this, Path of the Sun, Part 1. And I'll kind of walk you through this so that you should be able to do it successfully on your own. If we were in the classroom, we would use clear plastic domes to represent the celestial sphere. And we would use dry erase markers and actually make lines and marks on the dome. Just to review, the celestial sphere represents the sky, and the celestial sphere is really just a concept. It's not really an actual thing, but it represents, well, your view from wherever you are, and we can see this stick figure in the center. The celestial sphere is just what you can see wherever you happen to be. So if you imagine yourself being the stick figure, well, you can see up and you can see down to the horizon in different compass directions. And the celestial sphere is just really wherever you happen to be. It's just what you see in the sky. Now, the first thing that I want you to do when you open this up is to make it a little simpler to look at. We're going to simplify it a little bit. And under general settings, we're going to uncheck some things and just essentially declutter a little bit. I like to take the underside of the celestial sphere away because that's not something you would ever see in real life. The ground would block your view of that anyway. So I think that this gives us a more realistic view of what you would actually see if you were to look outside. So we could see what it would look like looking to the north, to the south, to the east, or the west. And on the computer, we can click and drag, and we can see what it would look like directly from above. And there you are in the center. I'll flip it around so north is up. Maybe that'll be a little less confusing. But there we have it. So now north is toward the top, south, east, west. And again, you would be underneath the zenith. The zenith is the point directly overhead. The horizon would be the ground. So now we can see what our view would look like for a person at different locations. So we can change the latitude. And we can change the latitude by punching in the latitude on the computer, or we could even grab this bar and slide it up and down. You might want to play around with that. We could change the time of day and the day in the calendar year. So we have the ability to go to anywhere in the world for any day or time, and we can see the celestial sphere. Now, last week I asked you to get Stellarium working, and we're going to use Stellarium soon, but I wanted to start out with this because it's a little bit simpler. Even though it might not look like it. So let's take a look at what you need to do. Okay, so there's a little introduction here, and it talks about how the reason that we see these different changes has to do with our revolution around the sun, which takes 365 days a year. As we orbit the sun, we see different things in the space in a calendar year. We have that tilt of 23.5 degrees, and we rotate on our axis once a day. It's tilt that causes the changes in the seasons, and we'll spend more time on seasons as we progress. And that rotation every 24 hours causes our day and night. There's some vocabulary to do, just like a lab, and some of these things you might want to look up. But let's go to what we actually need to do. So it says, enter the day of the year, December 21st. So we're going to switch to December 21. December. I'm going to go to 21st. I just typed that in. 21st. So now we're on December 21st. And it says enter the time of day 8 a.m. So now we need to change it to 8 o'clock a.m. I'm going to make that 8. And I'm going to switch this to a.m. And it's dark. It's December. As you know, it's dark much more in the wintertime. December 21st is the first day of winter solstice, the first true day of winter. And we can see the sun is just beginning to rise over here. It says enter the latitude, 41 degrees roughly for Goshen. We're about there, 40.8. I'm just going to leave that. That's close enough. So we're basically in a place similar to Goshen. on December 21st, 8 o'clock a.m. Now, if we take a look at what we have here, it's kind of interesting. The stick figure represents you and what you could see. Now, most people are very aware that the sun rises in the east and sets in the west. Well, that's only sort of true. It really depends on what time of year it is. If we look toward the east, and I'm going to zoom in a little bit. Well, let me do that. But if we look toward the east, we could see, well, the sun is rising in the east, but not right on east or due east, we would say. The sun is actually rising to the south of east. It's not right directly on east. In fact, that would only happen on the equinoxes, September 21st and March 21st. All other times of the calendar year, the sun is either going to rise to the south of east or toward the north of east. Let's go back to the worksheet. So now it says uncheck the ecliptic option. We did that. Animation speed 2 hours per second. What the computer is going to allow us to do is to speed up time. I'm going to drop this down to 2 hours per second. That's the animation speed. And when we click on Start Animation, we'll be able to see how the sun moves through the sky at this time. Rotate the celestial sphere so that you are looking from the southwest. Your celestial sphere should match figure 2. That I deleted that actually. That I should have removed. But now it says click to start animation. Allow approximately 3 to 4 days to elapse. Watch as the sun moves, causing our day and night in this early winter snapshot. Your answers, I need to change this from 8 to 12. It's these questions here, 1 through 9. I had to make some changes to this worksheet to work with the web version of the program. I'll go back and fix those numbers before I post this. So we're really talking about starting the animation and answering questions 1 through 9. So let's take a look at the questions. Well, on December 21st, to see the sun rise, you're going to look east, but you're not looking due east. You're actually looking to the south of east. Let's look at question 2. In what compass direction would you look to see the sun set on December 21st? So now we're actually going to start the animation, and we'll see how the sun moves through the sky. It does rise in the east. I'm going to stop it here. But it doesn't go straight up and over east to west. It takes a curved path through the sky. It starts in the southern half of the sky, rises south of east, moves across the sky, and sets south of west. Okay, there's sunset there. So it doesn't simply just rise in the east and set in the west. It rises south of east, moves across the sky, and sets south of west. So that would be question 2. For question 3, it says, what is the maximum altitude the sun reaches on December 21st? Well, let's go through another day. So now it's nighttime. The nights are long in the winter. There's sunrise again. The sun's coming up. And the sun is at a maximum right about there. This would be what's called solar noon, which is when the sun is highest in the sky. It doesn't necessarily match 12 o'clock noon. Okay, and there's some questions about that later on. The question on this one is asking about the altitude of the sun on December 21st. How high is it above the horizon? Well, let's see. Altitude 25.8 degrees. It says it right there. Okay, so 25.8. That would be the angle between the horizon and the sun. So 25.8 degrees there. The sun is low in the sky this time of year and is out for a short period of time. And that's, of course, why it's winter and it gets cold. In what compass direction would an observer face to view the sun at its highest altitude during its daily trek across the sky? Well, now we're seeing it due south. If I change the direction for the observer, when it's at its highest point, we would be looking due south. Maybe I could get it to line up just a little bit better. Let's see. I missed it. But due south is when it's at its highest point. Let's see. What term is used to describe the sun at its highest point? That would be solar noon. For number 6, for an observer in New York State on December 21st from sunrise to solar noon and ending with sunset, the winter sun passes through the observer's northern sky, southern sky, or both. Well, if we go back to sunrise, so now it's night, we'll wait for sunrise again. There's the sun. The sun is rising in the southern half of the sky. So here's our line dividing west-east. The sun is rising in the southern half, and over the course of a day, it moves across the sky, and it sets in the southwest, and it is always in the southern half of the sky. This is not true for other seasons. So that would be the answer number 7. It says refer to table 1 and explain why an observer's shadow points in both the northern and southern direction during the course of an entire day on June 21st. So now the table has been deleted. I need to make some changes to that worksheet, but we're going to go to June 21st. So now I'm going to go to June. This is summer solstice, which we're approaching. This is the first day of summer. We can see it's daytime. The sun takes a much longer path through the sky. Now here we have sunrise. And now we can see the sun is rising in the northern half of the sky, north of east, and it's taking a much longer path through the sky, and it sets in the northwest. Now, something to notice here, too, is that the sun is never directly over our heads where we live here in Goshen. That's not something you would ever see where we live. You have to be closer to the equator to ever have the sun directly over your head. So if we go back to this question, it says, explain why an observer's shadow points in both the northern and southern directions during the course of an entire day on June 21st. Well, if we go through a day and we look at the shadow, we can see the sun is in the northern half of the sky for part of the day. There it is, rising in the northern half. And now it's in the southern half of the sky. And we can see the shadow is changing. The shadow, the person's shadow, the stick figure shadow, is going between the southern half and now to the northern half. I'm going to stop the animation. Then it says, write a brief hypothesis as to why this important daily high point for the sun's movement is referred to as solar noon and not simply noon. Okay, this you might need to Google and look up a little bit, and I'm going to leave that part to you. So I really tried to help you out with this as much as I could and really walk you through it. But you are going to have to do a little bit of work on your own to find some of these answers. And we're going to do several parts to this. This was just part 1. You also might find these websites helpful, Stellarium and this Analemma website as we get further along, but we're just not there yet. Okay, so anyway, that's kind of an introduction to using this Path of the Sun simulator. And hopefully you're able to work through that, answer the questions. I'm going to update this worksheet slightly, and you should be good to go. We'll use it more as we go along. And you might want to just play around with this and see what happens at the North Pole, South Pole, down at the equator. Those are things that we'll play around with in the future too. Concept of the celestial sphere, it's just what the observer can see. So you are wherever you are is where your celestial sphere is. It's just a concept. Okay, so that's all for now. And let me know if you have any trouble.